Welcome to your math class.
Yeah, it's your faithful math servant for sure. And we are looking to factor fully here. So in these cases, we have our first step is always look for common factors. Here my only common, I'm going to use the equal sign, most powerful tool in math. My only common factor is an x. And if I write this down, I would have 5x squared minus 1. Because if I were to expand that back in, if I were to do my distributive property, I would recreate that and I would recreate that. I need the 1 there because it's a kind of target for my multiplication as I multiply that factor back in. So that one is done. Final answer. That's fully factored. Nothing else we can do there with that. Now over here. Oh, we got even more common factors. We have 3 and x are our common factors. 3x times x would be 3x squared, and 3x times 3 would be 9x. So that's done fully factored. Over here, x squared plus 17x plus 72, well, I'm going to use the equal sign again. I'm going to play an x game where I multiply to 72 and add to 17. Your calculator, your multiplication table, your factor knowledge will tell you that's 8 and 9, and both positive. So in this case, it's x plus 8 times x plus 9. I encourage you to check your work. So you do this. X times x is x squared. This is 9x. This is 8x. And this is 72. Checking your work means you're seeing the process of fold it in and unfold it back out. I can see that 9x plus 8x would make 17x. So I'm very confident in my answer and I move on. Here we go, team. So this one, I noticed that -5 could be a common factor. I would then have the rest of the party still inside the party here. -5 times x squared gives me -5x squared. -5 times positive 13x would give me -65x. And -5 times -30 would give me positive 150. So that's factoring out the -5. Notice I keep the -5 out there. I don't just like get rid of him or her. It just hangs out. And then I play an x game where I'm multiplying to -30 and I add to 13. Those numbers are 15 and -2. So then we go here -5 times x plus 15 times x minus 2. Thank you, Delta Math, for that saucy green circle problem. That's fairly challenging for green circle. Oh, we had to have one. We will have one that's challenging in green circle. It's a skill. We're supposed to be able to do this. So with these, we have no common factor. 23 is prime. 5 is prime. 12 is not prime, but it doesn't contain factors 5 nor 23, so we don't have a common factor here. So we play a special x game where we're multiplying to 5 times 12 and adding to 23. 5 times 12 is 60. 23 is 23. I happen to know that 3 times 20 will give me 60 and add to 23. So there we go. Now I use that knowledge. This is my way of doing it. You may have learned a different way on Monday. I split up that 23x into plus 20x plus 3x. And then I have plus 12 over here. Now I have 2 pieces that can common factor. That now has a common factor of 5x. And I would multiply it by x plus 4 to make the other stuff. This one has a common factor 3, and it's positive. So I write plus 3 multiplied by x plus 4. Notice that we ended up with the same binomial factor twice. That's the magic. That's the magic of these that you need to create to factor them correctly. Final answer would be 5x plus 3. The kind of leftovers that aren't in the brackets multiplied by x plus 4. And then you check your answer, you distribute all that stuff, and you get this back, and you're happy. You know that you did it right. Okay. This one here is a difference of squares. x squared minus 4. I could do this with an x game where I multiply to minus 4 and add to 0. Those numbers are 2 and minus 2. Or I can just remember that these always factor into x plus 2 times x minus 2. The square root of this one plus the square root of that one multiplied by the square root of this one minus the square root of that one. Let's keep going. Oh, we're into blue square, so we're going to work in orange for fun. And I notice common factors. My goodness, but the common factors are janky. They're bigger. I think a 10 is a common factor of 110. 130. And x squared is a common factor. So I would then have this multiplying 10x to the 2 to make 100x to the 4 minus 3. Done, final answer. Use the equal sign. This can't factor. I check it briefly. There's nothing I can do in there to factor it. It's not a difference of squares or something fancy. It's not trinomial. Okay, this one here is just again, I'm going to multiply to 5 times 9, which is 45, one of my favorite numbers, and add to minus 18. I happen to know that minus 3 times minus 15 will multiply to positive 45 and add to minus 18. I just know my multiplication table, so I don't want to tell you. So I do these fast. So now I use that to split this up. This is now 5x squared minus 3x minus 15x plus 9. Common factor, both bits. This one, the common factor is just x times 5x minus 3. And this one, our common factor is 3 minus 3 times 5x minus 3. Notice we have 5x minus 3 twice, which is great news. So we're going to have 5x minus 3 multiplied by x minus 3. Done, final answer. You can, of course, check it by expanding it and see if you get that. I'm not doing that all the time this time, but just know that I am doing it in my head very quickly to verify my work, because I don't want a mistake in here. Oh, look, this one has a common factor. The common factor is 2. So I'm going to write that this is equal to 2 multiplied by 2x squared plus 7x minus 9. Now I do this special x game again where I multiply to 2 times negative 9, and that's negative 18, and adds to 7. Multiplying to 18 and adding to 7 is not hard. It's 9 and minus 2. So I rewrite again. This is 2 times 2x squared plus 9x minus 2x minus 9. Again, write it again. Notice I have not destroyed that 2. It's still there. X times 2x plus 9 minus 1 times 2x plus 9. Okay, I'm going to factor out a negative 1 from here so that I get the same binomial factor in both places, just getting my signs right. There. And then final answer, this is 2 multiplied by 2x plus 9 multiplied by x minus 1. Done. This one here, great big common factor. Oh my goodness, here we common factor out a minus 5x. That would need to multiply by x squared minus plus x minus 42. Okay, that will be equal to negative 5x. Notice that negative 5x has to stay there. It's part of the problem. X plus 7 times x minus 6. How did I know that? I know my 42 times tables, or my ways to multiply to negative 42, and add to 1. This is the number 1 here. Okay, so that's where that 1 came from. And I know that 7 and minus 6 will do that, so that's how they ended up in there. All right. This was what you wanted, wasn't it? Someone tell Miss Brown that I think I'm to the problem she wanted to see. Here I have a common factor. My common factor is 5. I would multiply 5 by 6x squared plus 7x minus 24 if I wanted to recreate that line above. And now I have a very fancy x game to play. Of course, it's black diamond. I want to multiply to 6 times minus 24, which happens to be negative 144, and add to 7. So I'm going to look at my ways to multiply to 144 here. 144 times 1, well, that's not very good. Let's try 12 times 12. 12 times 12 also gives me 144, but that has difference of 0. So what if I think about 12 as 2 times 2 times 3, multiplied by 2 times 2 times 3, and then I group this a little differently. I'm going to take these 3's and put them together, and take all these 2's and put them together. So then I would have 2 times 2 times 2 times 2, that's 16, and 3 times 3, that's 9. 16 times 9 works. And if I had positive 16 and negative 9, those would add to 7. So that gives me 5 multiplied by 6x squared plus 16x minus 9x minus 24. I use these magic numbers to break up this middle term. Still equivalent, everything's equivalent. And then I factor 5 times 2x multiplied by 3x plus 8. That recreates those two terms up here. And then these two terms have common factor minus 3. Times, 3x plus 8. Okay, and then we finish this off this way. 5 times 2x minus 3 times 3x plus 8. Oh, what a delight. Okay, now let's work on this one over here. Pion, like that. Okay, we've got a, this is equal to, I see a common factor 2x. And that's going to be x to the 4 minus 81 in the brackets. Okay. X to the 4 minus 81 is the difference of squares. So that's going to be 2x times x squared plus 9 times x squared minus 9. Oh, x squared minus 9 is also a difference of squares. So this is 2x times x squared plus 9 times x plus 3 times x minus 3. Okay, so this difference of squares broke into those two pieces, but that piece is itself a difference of squares which breaks into those two pieces. Black diamond, it's tricky. But it's all equivalent. I could check my work by re-expanding and simplifying, and I would get back this because I did this right. Okay, now here, we've been asked to solve. This is a little bit different than factor, but it uses our knowledge of factor in order to do that. Here I have two things that multiply to 0, so one of them must be 0. So that is to say either x minus 3 equals 0, or x plus 5 equals 0. And in these cases here, we're going to work in blue. This is x equals 3, and this is x equals minus 5. Circle both so that I see both your answers. They both correct. This one also is a quadratic because it has an x squared, and it also has two answers. But this one just common factors. X times x minus 9 is equal to 0. So that means either x equals 0, that's that x equaling 0, or x minus 9 equals 0, and x equals 9. Answer, answer. Correct, correct. We could substitute those in there and they would be true. Let's keep going. What if we had one of these funky trinomials factored like that? It's the same. You go 2x minus 3 equals 0, or 3x plus 5 equals 0. In this case, we add 3 to both sides, and we get 2x equals 3, and then we divide both sides by 2, and we get x is equal to 3 on 2, or 1.5. Both correct. Over here, we subtract 5 from both sides. We get 3x equals negative 5, and then we divide both sides by 3. X equals negative 5/3, which equals, oh, it makes me want to barf a little bit, negative 1.6 recurring. There's an answer, there's an answer. Both correct. This one here, oh, we would have to factor to find that one. I need two numbers that multiply to 6 and add to negative 5. Those numbers happen to be negative 2 and negative 3. So this factors into x minus 2 times x minus 3 equals 0. And now this one gives me x equals 2, and this one gives me x equals 3. Two answers. I could, again, substitute those in there to check my answer and make sure they equal 0 when all is done. And they do. I'm not going to show you, but you can check. Okay, let's take a look at some blue square. Oh man, this one is actually a little tricky. Okay, so we are going to subtract 2 from, let's work in orange, because I don't know why. I like working in orange. Let's take away 2 from both sides, and then we get this. 3x squared minus 7x minus 2 equals 0. We want this situation with quadratics. We want to push everything to one side of the equal sign so that we set the whole thing equal to 0. That way we can solve it by factoring. Now we play this special x game where we multiply to 3 times minus 2. That's minus 6, and add to minus 7. So we want to multiply to minus 6 and add to minus 7. Do I have an error? Yeah, I have an error here. So that one won't factor. Yeah, my dear.
This is your 2-minute warning to turn on all your projectors in preparation for our
No, you hate you.